projectile is anything that's kind of thrown through the air and falls with gravity. And projectiles follow a parabolic path due to this gravitational acceleration. So a mountain biker follows a path that's modeled by this parabola. Okay, it's going to be, I'm just going to maybe sketch this out. We have a parabola, another 0 here, and it looks like the other 0 is going to be at 8 over 5, so like 1.6, maybe somewhere out there. Okay, and so, and maybe I'll just write that out, y equals, and the way I got that is I just factored the x out, and I ended up with negative 5x plus 8, and I can solve for the x. I end up with 0 and 1.6, or 8 over 5. And it's going to be an upside down parabola. The vertex kind of is going to go up and come back down like that. And the landing is modeled by 2x plus 4, and that's the point at which the mountain biker hits the ground. Okay, so this is going to be, maybe just make it a little bit more like this, and it's going to hit the ground kind of like that. Okay, so which hits the landing, and the mountain biker is going to hit the landing, and he's going to kind of go like that. So it's going to be kind of a tangent point there. And so what we want to do is we want to find out at which point the mountain biker is going to hit the landing. And so we need to solve this, find the intersection point of these two graphs. So I'm going to again make the y's equal to each other and solve this. So I end up with a quadratic equation again. So I'm going to make it equal to 0 on this side. So I get 5x squared minus 10x plus 4. We'll need to see if we can factor this. This is not factorable, so I need to plug this into the quadratic formula. So I end up with x is equal to 10 plus minus 100 minus 4 times a times c. And that's all over 2a. Okay, so then simplifying this, I end up with 10 plus minus 16 times 5 is 80, so square root 20 over 10, and it simplifies to 5 plus minus square root 5 over 5. Okay, so there's my solution. So this is approximately equal to 1.44. Okay, so it's going to be a point somewhere here, 1.44, and minus 0.5, looks like 0.527, or 5527, so somewhere around here actually. So it's going to, let's maybe work this out, so it's going to be 0.55, like that. So let's redraw this. It's going to be more like this. It's going to be a little bit closer to here, this end, and it's going to basically kind of cut through like that. Okay, and so there's my two intersection points, and this guy is going to come down and follow this path. So it's going to come up, hit the ramp, and then kind of run out in that direction. Okay, so we need to then write this as a piecewise function. Okay, so then when I graph this, so I could just move my graph into here. Okay, so there's what my graph looks like. And I want to write this as a piecewise function. This is my point at which I transition. Okay, so I need to have two parts. So I'm going to do this as a green part and a red part. So as a piecewise function, it's going to look like this. My f of x is equal to, and I have my domain, is going to be from 0 to 1.44. And the equation is going to be the parabola portion of this, which is negative 5x squared plus 8x. And for the domain, from 1.44, I'll include the 1.44 on that point. From that point to where it crosses the x-axis, or sorry, to cross the x-axis here. So where the green line crosses the x-axis, that's going to be where x is equal to 2 seconds. Okay, so I can solve this equation equal to 0, and that's going to give me my endpoint there. So from 1.44 to 2 seconds, it's going to follow negative 2x plus 4. Okay, so there's my piecewise function. There is a green piece here and the red piece here. The parabola is described by this piece in this domain. The linear part of this is described by this linear function in this domain.